Hello. In this movie, we're gonna think about Chapter 7, Settlement. Uh, when when plaintiff sues defendant, so plaintiff sues, they eventually they may go to trial. So when they go to trial, judge is gonna make decision. So if plaintiff wins, defendant has to give him money, and if defendant wins, he doesn't pay. But before they go to trial, there is a process called settlement. So in this step, defendant is going to offer some money to plaintiff, and plaintiff accept this money, then they don't go to trial. So here at settlement stage, defendant is going to pay, defendant is going to offer some money to plaintiff. So if plaintiff accept this money, then the game is over here, and they don't go to trial. And in reality, many cases are settled without going to trial. So according to some data, it seems that less than 4% of civil cases are going to trial in the end. So almost all cases are settled and they don't reach trial eventually. So studying settlement process is very important when we study litigation process. So before we start thinking about settlement stage, we're going to think about some concept called discount factor. So we have to think about this concept called the discount factor before we study settlement. So think about today and tomorrow. So today you give $8 to the bank. Then tomorrow it's gonna be, so A is your money plus you're gonna get some interest. So let's say R is interest rate. Then tomorrow you're gonna get this much money in your bank account. So if you have $8 today, it's gonna become 1 plus R times $8 tomorrow, and R is interest rate. So you can say this is a future value of $8 today. So today's $8 will become 1 plus R times $8 tomorrow. So we can say this is future value of today's $8. Suppose you have $B tomorrow. So suppose we have $B tomorrow. Then what must be today's amount if you want to get $B tomorrow? So it must be this much money. So if you have this much money in the bank account, we multiply 1 plus R, then it's gonna be $B tomorrow. So we can say this expression is present value of $B tomorrow. So we can say this expression is present value or today's value. So this expression over here is present value of $B tomorrow. So you can see that when we calculate the present value of $B tomorrow, this present value is having discount in the sense that in nominal value, this present value gets smaller. So for example, B is $100. So this is $100 tomorrow. Then present value of $100 tomorrow is gonna be maybe 95. So it's gonna be discounted through this term. So we can say so you have B dollars, so you expect to get B dollars tomorrow. Then what's gonna be this B dollars tomorrow? This B dollars today's value or present value. We're gonna multiply 1 over 1 plus R to B dollars. Then we can convert tomorrow's value to today's value. And this term is called discount factor. And in short, let's say we're gonna write this down as delta. So you expect to get some amount of money tomorrow. Then we're gonna discount the value when we calculate today's value or present value of tomorrow's money. And let's say, so this is today, time period 1, time period 2 is tomorrow, the day after tomorrow. Then let's say you're gonna get C dollars the day after tomorrow. Then what is the present value of this C dollars? So you're gonna multiply. So first so you're gonna multiply discount factor once to calculate tomorrow's value of C dollars the day after tomorrow. And you multiply discount factor one more time to calculate present value. So here you multiply discount factor twice. It means that you are calculating present value of the money in time period 3. So this is how we calculate present value. So present value of future money. And calculating present value is really important because we want to compare money in different time period. So for example, suppose time period 1, time period 2. So this time period 1 is today, time period 2 is tomorrow. Let's say you want to compare two things. Let's say $99 today and $100 tomorrow. So if someone tells you, if someone asks, which one is better, today's $99 or tomorrow's $100? So in this case, it's not clear because you cannot just say, 100 is bigger than 99, so I prefer $100 tomorrow. You cannot say so because you cannot directly compare nominal values because these are expressed in different time period. So if you want to compare these two, you have to convert future money to present value, and then you can truly compare these two. So, if you want to do that, multiply discount factor to tomorrow's money, then this value is gonna be now present value. So 99 and delta times 100, these two are expressed in today's term. So now you can directly compare nominal values. But before you calculate present value, you cannot just compare these two because they are expressed in different time period. So when we study chapter 7 settlement, we have to think about this kind of discount factor. because settlement is today and going to trial is tomorrow. So there is a natural time difference between settlement and trial. Okay, so before we move on, so imagine. So when the case goes to trial, plaintiff's payoff is expected judgment X minus litigation cost, and defendant's payoff is minus X minus litigation cost. So when they go to trial, this is their expected payoff. This means there is a settlement value for both of them. So in particular, if they can settle at S dollars, and this S dollar is a number between these two numbers, then it is better option for both of them. So why? Because now, for example, they settle at this amount. So here, settlement at S dollars means defendant offers S dollars to plaintiff and plaintiff agrees. So the game is end here. Then this is better option for both of them, because think about plaintiff. Plaintiff is gonna get S dollars from defendant. If plaintiff goes to trial, he obtains X minus CP. So if you see this graph, S is bigger than X minus CP. So plaintiff is better off by having settlement at S dollars. What about defendant? If defendant goes to trial, he has to pay this much money. So this is his total cost at trial. So defendant has to pay X dollars to plaintiff, and defendant has to pay litigation cost. But if defendant can settle at S dollars, defendant is gonna pay S dollars to plaintiff, and that's it. So as you can see, in this case, defendant is also better off because he can lower his cost. So therefore, there is settlement value for both of them. If they can settle in this range, then it is better for both of them. This is why settlement is so often. So in many cases, litigants settle with each other and they don't go to trial. And this is better for litigants, and it is also better for society if they settle, because there is no waste of litigation cost. So litigation cost can be considered as a pure waste for society, because litigation cost cannot it cannot create something. So it's just gone from our society. So we can consider litigation cost as a pure waste. So if we can reduce pure waste, it is better for society. So in this sense, having settlement without going to trial is better for individuals, and it's also better for society. Okay. Now let's think about how they settle with each other. So let's assume X is bigger than CP. So in this case, plaintiff has incentive to sue, and plaintiff has incentive to go all the way to trial, because if plaintiff goes to trial, his expected payoff is positive. In this case, So when they go to trial tomorrow, plaintiff's payoff is X minus CP, and dependent's cost is X plus CD. And before they go to trial, suppose plaintiff has a chance to make a settlement offer. So suppose before they go to trial, plaintiff has a chance to make a settlement offer. So plaintiff settlement offer means plaintiff is gonna demand certain amount of money from dependent, and if dependent rejects, then there's no more opportunity for settlement, so they go to trial tomorrow. Now then, in this case, if plaintiff offers a settlement amount S dollars, what is the best choice for plaintiff? So if plaintiff has this last chance to make a settlement offer, how much would he offer? This is the question. So suppose plaintiff offers S dollars. So plaintiff offers S dollars. It means plaintiff demands S dollars from dependent. So if dependent accept, then dependent gives S dollars to plaintiff, and that's it. If dependent rejects, then they go to trial tomorrow. So in this case, dependent is gonna compare S and X plus CD. So dependent tries to lower his cost. So he's gonna choose the option with lower cost. But he cannot directly compare S and X plus CD because S is expressed in today's value and X plus CD is expressed in tomorrow's value. So dependent cannot directly compare them. So dependent has to calculate present value of trial payoff tomorrow. So how does he do that? He's gonna multiply discount factor delta, and then he can compare these two. So therefore, dependent is gonna accept plaintiff offer if S is lower than or equal to present value of trial payoff. So otherwise, if S is bigger, then dependent is going to reject. So they go to trial tomorrow. So plaintiff knows this. So anticipating what's going to happen, plaintiff is going to try to maximize his offer so that dependent accept. Because if dependent reject, then it's also bad news for plaintiff, because as I said here, if they settle in this purple range, it is better news for plaintiff and dependent. So if possible, plaintiff wants to settle with dependent, and therefore when plaintiff thinks about his choice of offer S, this is constrained. So plaintiff wants to make an offer S less than or equal to this present value of dependent's trial payoff, and still, if possible, plaintiff wants to get as much as possible. So therefore, plaintiff is gonna demand exactly this much. So plaintiff is gonna demand exactly this much today. Then dependent is gonna accept, because S settlement offer is now exactly equal to present value of trial payoff. So dependent is gonna accept. So they settle today and they don't go to trial tomorrow. So in this case, we can see that because plaintiff, because plaintiff has this last chance to make a settlement offer, we can see that plaintiff gets the maximum amount, almost maximum amount from settlement. So here suppose delta is equal to 1, then this settlement amount is equal to this maximum amount possible from settlement. So in this way, when plaintiff has less chance to make a settlement offer, he can extract entire surplus from settlement. Now, what if dependent has less chance to make a settlement offer? So if they go to trial tomorrow, plaintiff's payoff is x minus cp. Dependence cost is x plus cd. If today dependent has this last chance to make a settlement offer S, so here last chance means dependent is going to offer S dollars to plaintiff. If plaintiff accept, then they settle today and that's it. If plaintiff rejects, there is no more opportunity for settlement, so they go to trial tomorrow. So in this case, how much dependent would offer to plaintiff? So suppose dependent offers S dollars to plaintiff, then plaintiff is going to compare S dollars and X minus CP dollars. But he cannot compare directly because these two amounts are expressed in different time period. So plaintiff is going to calculate present value of trial payoff tomorrow by multiplying delta. So now these two amounts are expressed in the same time period. So plaintiff can now directly compare these two. Therefore, plaintiff is gonna agree. So accept this offer as long as S is bigger than or equal to present value of trial payoff. So plaintiff is gonna accept as long as we have this inequality and dependent knows this. So dependent knows this. So dependent is going to choose S so that plaintiff accepts and at the same time dependent wants to lower settlement amount as much as possible. Therefore, we can see that dependent is going to offer exactly this much. So we can see that dependent, if dependent has this last chance to make a settlement offer, dependent is going to offer exactly this much, and this value is present value of plaintiff's trial payoff. So dependent is going to offer exactly this much, then plaintiff is going to accept and they settle today and they don't go to trial tomorrow. So again, in this case, we can see that when dependent has less chance to make a settlement offer, we can see that dependent can extract the entire surplus from settlement. So who can make the last offer is really important. Then what if for example, What if today plaintiff can make a settlement offer, and today dependent can make a settlement offer, and so today plaintiff makes settlement offer, and tomorrow dependent is gonna make settlement offer, and tomorrow is the last, so they cannot settle by tomorrow. Then no more settlement opportunity, so they go to trial the day after tomorrow. So if they go to trial, plaintiff is gonna accept this much, and dependent cost is this. So we have 3 time period in this case. So today plaintiff is gonna make a settlement offer. If dependent accept, they settle today. But if dependent reject, they go to tomorrow. And tomorrow, dependent is gonna make settlement offer. If it is accepted by plaintiff, they settle tomorrow. But otherwise, there is no more opportunity, and they go to trial the day after tomorrow. In this case, what's gonna happen? So in this case, so our first question is, when do they settle? Do they settle today, or do they settle tomorrow? Or is it possible they go to trial the day after tomorrow? And our second question is, if they somehow settle, they settle at how much? So what is gonna be the settlement amount in this case? Especially, as you can see, we can say plaintiff in this case is first proposer, and dependent is the last proposer. So we are wondering if being first is better or being last is better in this case. So plaintiff makes first offer, and is it better, or dependent is making last offer, and is it better to be the last? So we're gonna think about this issue here. So let's think about tomorrow first. So suppose they fail to settle today and they are in tomorrow. So tomorrow, when tomorrow comes, dependent is gonna make a settlement offer S. Then plaintiff is gonna compare S and X minus CP tomorrow. So remember, this is today. So when tomorrow comes, tomorrow becomes today. So dependent is gonna make settlement offer S dollars, and plaintiff is gonna compare S today and X minus CP tomorrow. So to do this, plaintiff is gonna calculate present value. So he's gonna compare these two. So plaintiff is gonna accept as long as S is bigger than or equal to this expression. Dependent knows this. So when tomorrow comes, somehow they cannot settle today and tomorrow comes, then dependent is gonna offer exactly this much. So dependent is gonna offer exactly delta times X minus CP. So in this case, plaintiff is gonna accept, and they're gonna settle tomorrow. So they don't go to trial. It is not possible for them to go to trial. So if they fail to settle today, we can be sure that they will settle tomorrow. So then now, think about today. So today, plaintiff has chance to make settlement offer. And here, when plaintiff makes offer, plaintiff knows that if they fail to settle today, they're gonna settle tomorrow. So knowing that, plaintiff is gonna make a settlement of S. Then dependent is gonna compare S and this amount. So dependent is comparing giving $S today or giving delta times X minus CP tomorrow. Again, dependent cannot compare directly, so calculate present value by multiplying delta. So now we have delta power 2. So dependent is compare these two. So dependent is gonna accept as long as S is lower than this expression. So dependent is gonna accept plaintiff's offer as long as delta, as long as S is lower than or equal to delta power 2 times X minus CP. Therefore, if plaintiff wants to settle today, he has to offer exactly this much. So if plaintiff wants to settle today, he knows that he has this constraint because S is bigger than this expression, then he cannot settle today. So if plaintiff wants to settle today, plaintiff has to offer exactly this much. Then in this case, dependent is gonna accept, so they gonna settle today without even going to tomorrow. So plaintiff may, in this case, plaintiff may be wondering, what if he settled tomorrow instead of settling today? And it turns out that plaintiff is indifferent between settling today and tomorrow, because if he settles today, he's gonna get this much money today. If he settles tomorrow, he's gonna get this much money tomorrow. But if you calculate present value of tomorrow's settlement amount, they're exactly the same. So this much money and this much money tomorrow is actually the same if you calculate present value. So therefore, plaintiff is indifferent between settlement today and tomorrow. So let's assume plaintiff is gonna settle today. Therefore, in this case, we can see that plaintiff and dependent will settle today right away without even going to tomorrow. And settlement amount is, as you can see, so that settlement amount is this much. So you can see that if delta is equal to 1, this is X minus CP, and X minus CP is from our previous graph. So this purple range, this is possible range for settlement, and we can see that X minus CP is the bottom. So in other words, in this case, dependent is extracting all surplus from settlement. So from this exercise, we can see that last proposal is better than first proposal. So by being last proposal, you become kind of gatekeeper in this litigation process. So you can extract all surplus by being last proposal. So in this settlement process, being the last proposer is the best. So here we thought about this simple model of settlement, and so one of the problem in this simple model of settlement is litigants never go to trial. So as we can see here in this exercise, it turns out that litigants always settle and they never go to trial. But in reality, litigants often go to trial, so we want a better model of a settlement that can explain both settlement and trial. So we're gonna do that with a slightly more complicated model of settlement in the next section.